All right, ready to dive into some more CompTIA plus 220 1101 goodness.
Let's do it. Today, it's all about networking the foundation of how devices talk to each other in the digital world.
Networking. Huh. So we're not just talking about, like, making friends at tech conferences.
Haha, not quite. We're talking about the systems and protocols that let you check your email, stream your favorite shows, or even just browse the web. Everything relies on networking these days.
Okay, so kind of important then. But where do we even begin with something as massive as, well, the entire internet?
We'll break it down into manageable bites, don't worry. First things first, what asks a network?
Back to basics. I like it.
At its core, a network is just a group of connected devices that can share resources, computers, printers, smartphones, you name it. Think of it like a digital neighborhood where everyone can share information and resources.
So my home Wi-Fi, where my laptop, phone, and smart TV are all connected, that's a network.
Exactly. That's a classic example of a LAN or local area network confined to a small area, like a home or office.
LAN, got it. But what about, like, the internet itself? That's not exactly local.
Good point. For larger, geographically dispersed networks, we use the term WAN, or Wide Area Network. The internet is the ultimate RAN, connecting countless smaller networks globally.
Okay, so LAN is my neighborhood, WAN is the whole planet.
Got it.
And I'm guessing the exam expects us to know the difference.
Absolutely. They might give you a scenario setting up a network for a small business, for example, and ask you to choose between a LAN and a WAN.
Makes sense. Now, how do all these devices on a network actually find and communicate with each other? It's not like they're shouting across the room.
That's where IP addresses come in. Every device on a network needs a unique IP address to communicate, like a digital fingerprint.
Right, those strings of numbers that look like something out of the Matrix.
Exactly. And the exam will likely quiz you on the difference between IPv4 and IPv6. IPv4 is the older standard, those four sets of numbers you mentioned.
So far, so good.
IPv6, on the other hand, uses a longer, more complex format to accommodate the ever-growing number of devices connecting to the internet.
More devices, more numbers.
Got it.
So is that like the only difference between IPv4 and IPv6, or?
Well, there's a bit more to it, but for the A+ dog, knowing the basic difference in their address formats is key. They might also ask about APPA.
APPA, that's a new one.
It stands for Automatic Private IP Addressing. Basically, if a device can't get an IP address from a DHCP server.
DHCP, that's like the network's automated IP address dispenser, right?
Exactly. So if that dispenser is down, the device will use APIPA to assign itself a temporary private address. This lets it talk to other devices on the same local network, but not access the internet.
Having a phone that can only make internal calls, not very helpful.
Exactly. Now, speaking of communication, let's move on to the hardware heroes that make networking possible. Modems, routers, and switches.
The hardware, those physical boxes that make the magic happen. Starting with modems, right? What exactly do they do again?
Think of a modem as a translator between your home network and your internet service provider. It converts digital signals from your devices into signals that can be transmitted over your internet connection, cable, DSL, or fiber optic.
So it speaks the language of the internet provider.
Exactly. And on the flip side, it receives incoming data and translates it back into a language your computer can understand.
Like a digital interpreter. But the modem alone doesn't handle everything.
Right.
Well, that's where the router comes in.
You got it. Once that internet signal is in your home, the router steps in to direct traffic between the internet and your devices, making sure data gets where it needs to go. Plus, it lets multiple devices share that single internet connection.
So if the modem's the translator, the router's like the air traffic controller.
Perfect analogy. And speaking of directing traffic, we can't forget about switches, especially in larger networks.
Switches. Those are just like multi-port adapters, right? You plug in a bunch of devices and they're all connected.
They might look similar, but switches are smarter than you think. They actually learn the addresses of connected devices and forward data only to the intended recipients, making the network much more efficient.
Okay, so instead of shouting to everyone in a crowded room, a switch allows for private conversations.
Precisely. And here's another term you'll definitely want to know for the A+.PoE.
PoE, power over Ethernet. So like powering devices through the Ethernet cable itself.
You got it. PoE is super handy for things like VoIP phones or security cameras, eliminates the need for separate power adapters.
That's pretty slick. Okay, so we've covered the basics of networks, IP addresses, and some essential hardware. I'm feeling a bit more confident already.
That's great to hear, but we're just getting started. Next time, we'll unravel the often overlooked world of network cables. Trust me, there's more to it than meets the eye. Welcome back to the deep dive, ready to tackle another layer of networking knowledge.
Bring it on. What's up next?
It's time to untangle the world of network cables. We've talked about what signals they carry, but choosing the right cable can make or break your network's performance.
Okay, network cables. I'll admit, I usually just grab whatever's cheapest online. What's the big deal?
Don't they all do the same thing?
Not quite. Think of it this way. You wouldn't use a garden hose to supply water to a fire hydrant, right?
Okay, that's a bit extreme.
The point is, different cables have different capabilities. Choosing the wrong one can mean slow speeds, bottlenecks, even security risks. And the A+ exam will definitely test you on this.
All right, you've got my attention. What are the main cable types we need to know?
We'll start with the classic coaxial cables. You might recognize those from older cable TV setups. They've got that single copper core with insulation and a braided shield.
Right, those ones are pretty sturdy. But you're saying they're not so common for computer networks these days.
True. They offer decent bandwidth, but they can be bulky and prone to interference. You're more likely to see them for things like connecting a cable modem or in older installations. Good to know, but not the star of the show anymore. What about those twisted pair cables? Those are the ones I always see for Ethernet connections.
Exactly. Twisted pair cables are the workhorses of modern Ethernet networks. They've got pairs of copper wires twisted together.
The twisting, that's to reduce interference, right?
Exactly. It ensures a cleaner signal. Now, you'll see different categories of twisted pair cables like Cat5e and Cat6.
Right, Cat5e, Cat6. What's the deal with all the different cats?
The cat just refers to the category, and each category has different specs for speed and bandwidth. Cat5e is common for homes, and small offices support speeds up to 1 gigabit per second.
So for everyday stuff like browsing, streaming, even light gaming, Cat5e should do the trick.
In most cases, yes. But if you need to handle more bandwidth-intensive stuff like high-res video editing or large file transfers, you'll want to go with Cat6.
Because Cat6 is faster.
Much faster. We're talking up to 10 gigabits per second.
Wow, okay, that's impressive. So Cat6 for the speed demons. But what about fiber optic cables? Aren't those supposed to be insanely fast?
Fiber optics. They're in a league of their own. Instead of electrical signals, they transmit data using pulses of light.
Light speed internet, literally.
Exactly. We're talking crazy fast speeds, no interference, and they can span much longer distances than copper cables. That's why they're used for those massive internet backbones in data centers.
Okay, so fiber optic is like the VIP section of network cables.
Yeah.
But I bet they come with a VIP price tag, too.
They can be more expensive to install, that's true, but the price has come down, and for some situations, the benefits definitely outweigh the costs.
Makes sense. So we've got our cable basics down. What's next on this networking crash course?
Let's zoom out for a bit and talk about network models. Specifically, the OSI model.
OSI model. That rings a bell, but refresh my memory.
Think of it as a blueprint for understanding how data flows across a network. It divides network communication into 7 distinct layers, each with its own function.
7 layers. That sounds a bit intimidating. Like some kind of networking lasagna?
It's not as complicated as it sounds. The key is that each layer has a specific job to do. At the very bottom, you've got the physical layer. That's where we're dealing with the raw transmission of data over those cables we were just talking about.
Okay, so the physical stuff, cables, connectors, signals. Got it.
Right. Moving up, we have the data link layer, which ensures reliable data transfer between directly connected devices. It's like adding addresses and error checking to those data packets.
Makes sense.
Yeah.
So what's next in our networking lasagna?
Above the data link layer, you've got the network layer. That's where routing happens, figuring out the best path for data to travel across multiple networks.
Ah, so that's where the router we talked about earlier does its thing.
You got it. Then we have the transport layer. This one makes sure data transmission is reliable from start to finish. Think of it like a quality control manager.
So no matter how the data gets there, this layer ensures it arrives correctly.
Exactly. And we're only halfway there. Up next is the session layer.
Session layer. What does that one do?
It manages the connections between different applications. Think of it as the meeting organizer for network communication.
Okay, so making sure those data conversations start and end smoothly.
Precisely. Then we have the presentation layer. It handles things like data formatting, encryption, decryption.
So it's making sure all the devices are speaking the same language.
Exactly. And finally, at the very top, we have the application layer. This is where we humans actually interact with the network, using things like web browsers and email clients.
Okay, so 7 layers, each with its own important job. But why do we even need to know all of this? Is the A+ exam going to make us build a network from scratch?
Maybe not from scratch, but understanding the OSI model is key for troubleshooting. If something goes wrong, knowing which layer a problem's occurring in can help you pinpoint the cause and fix it faster.
Like a diagnostic tool for networking.
Exactly. Now let's shift gears and talk about something that ties all these layers together. TCP/IP. Ever heard of it?
TCP/IP. Rings a bell. Isn't that like the language of the internet?
Bingo! It stands for Transmission Control Protocol Internet Protocol. It's a set of rules that govern how data is transmitted online. Everything you do online relies on it.
And the A+ exam probably expects us to be fluent in TCP/IP.
You bet. They'll want you to understand the key protocols within TCP/IP, especially TCP and UDP.
TCP, UDP, those sound familiar, but how are they different?
TCP, or Transmission Control Protocol, is what we call a connection-oriented protocol. It focuses on reliability, making sure data is delivered in the correct order, even if it's broken down into smaller packets.
So like sending a package with tracking and delivery confirmation.
Exactly. Now, UDP, or User Datagram Protocol, is connectionless. It prioritizes speed over reliability, like sending a postcard, no guarantee it'll arrive, but it'll get there faster if it does.
Okay, so TCP for when you need everything to be perfect, and UDP for when speed is king.
You got it. TCP for things like browsing and email. UDP for things like streaming or online gaming, where a few dropped packets won't ruin the experience.
Makes sense. So where do ports fit into all of this? We touched on those earlier, right?
Oh, absolutely. Remember, ports are like virtual doorways within a device, allowing different applications to send and receive data over the same network connection. Each port has a unique number.
Right, like having multiple phone lines coming into your house, each with its own number.
Perfect analogy. And certain well-known ports are associated with specific applications. For example, port 80 is used for regular HTTP web traffic, and port 443 is for secure HTTPS traffic.
So if we see those port numbers, we know what kind of traffic is happening.
Exactly. Understanding ports is super helpful for troubleshooting, configuring firewalls, and spotting security risks. Speaking of security.
Ah, yes. We've talked a lot about building networks, but how do we actually protect them?
Great question, and that's a whole other can of worms, but a super important one for the CompTIA A+ exam. Get ready to dive into the world of firewalls, encryption, and more.
Welcome back. So last time we left off talking about network security, a pretty crucial topic in the world of IT.
Absolutely, and it's not just about protecting big companies and their data. Every single person who uses the internet needs to be thinking about security.
True. So what are some of the biggest threats out there? Besides, accidentally spilling coffee on my router.
Haha, well, besides that, we're talking malware viruses, worms, trojans, ransomware, all designed to exploit vulnerabilities in your systems and software.
Okay, so those are the bad guys. And the A+ exam wants to make sure we can identify them.
Definitely. They'll want you to know how each type of malware operates and how to protect against them.
Got it. So how do we build those defenses? Let's start with firewalls. I feel like I hear that word all the time, but
Yeah.
what exactly is a firewall?
Good question. Think of it like a security guard for your network. It acts as a barrier between your trusted network and the outside world, the wild west of the internet. It monitors all the incoming and outgoing traffic, blocking anything suspicious.
Okay, so they're checking IDs at the door of our network, only letting in the good traffic.
Precisely. And they come in different forms, hardware firewalls, software firewalls, but they all essentially filter traffic based on rules. The A+ might ask about configuring those rules or the differences between hardware and software firewalls.
Got it. Firewalls, it's essential. What about encryption? That's another one that gets tossed around a lot.
Encryption is key, especially these days. It's all about scrambling data, making it unreadable without the decryption key.
So even if someone intercepts the data, it's just gibberish to them.
Exactly, like sending a secret message that only the intended recipient can decode.
I like it. What about passwords? I feel like that's pretty basic, but still super important.
You're telling me a weak password is like leaving your front door wide open.
And by weak, you mean like password 123.
Ugh, please no. The A+ exam will test you on password best practices, complex combinations, different characters, don't reuse passwords, all that good stuff.
Right, because a chain is only as strong as its weakest link. And I'm guessing a weak password is a cyber criminal's dream come true.
100%. They also might try to trick you into giving up that password. We call this social engineering.
Social engineering, like what friending someone on Facebook just to hack their account.
That's one way. Think phishing emails too. Those messages designed to trick you into clicking a bad link or giving away your login info.
Okay, so Be wary of any emails asking for your bank details or telling you you've won $1 million.
Right.
Got it. What else should people be aware of when it comes to network security?
Well, subnetting's a good one to know. It's a bit more advanced, but you might see it on the exam.
Subnetting. Sounds a little intimidating.
It's really just about dividing a larger network into smaller, more manageable subnetworks.
Okay, so kind of like dividing a big company into smaller departments.
Exactly. It helps with organization, security, and performance. The exam might ask you to calculate subnets or identify network addresses, so brush up on your binary math.
Noted. Binary math it is. So we've covered a ton of ground here. Any final words of wisdom for our listeners who are prepping for the A+ Cent?
Remember, network security is an ongoing process. Stay informed about the latest threats, use strong passwords, and be careful what you click on.
Right, because a little paranoia goes a long way in the digital world.
Exactly. And with that, I think we've successfully navigated the intricate world of networking. From the basics of what a network is to the complexities of subnetting and security. Congrats on completing this deep dive.
It's been quite a journey. Hopefully our listeners are feeling more confident and prepared to tackle those A+ exam questions.
We're here to help you every step of the way.
Until next time, keep those networks secure and those firewalls strong.